Hello. For those of you who don't know who I am, I'm Dr. Christy Mulkey, and I'm the workshop coordinator for 240 Tutoring. And I am live in our FTCE study and test prep group on Facebook. And today we're going to be finishing up our look at the general knowledge math exam. So the past several weeks, we've been going through and looking at competencies and standards and doing practice questions together and providing some strategies and some teaching for you as you prepare for your exam. So today we're going to finish up competency 4. So I'm going to share my screen with you so that it's easy for you to follow along. Just going to make sure that's sharing. Okay, looks like it's up and going. So again, we are finishing up looking at the math exam, and this is competency 4, skills 1 and 2, 6 and 7. And remember, these Facebook Live videos are designed to be specific to your test. So we're looking specifically at Florida test. We're going to talk through the competency, and I'm going to walk you through some strategies and hopefully give you some tips to help you do well on this exam. Now, last week, we talked about skills 3 through 5. I kind of lumped these together a little bit differently. So last week we looked at these skills 3 through 5 that had to do with measures of central tendency. So just lump those together because the questions go together so easily. Today we're looking at skills 1, 2, 6, and 7. So today we're looking at analyzing data presented in various forms, so lots of graphs and plots to solve problems, and we're going to talk about those a little bit in depth in just a moment. We're going to be looking at analyzing and evaluating the presentation of data. We're going to be looking at solving and interpreting real-world problems using probability with procedures, tables, all of that stuff. And then inferring and analyzing conclusions from sample surveys, experiments, and observational studies. Now, I said this last week, and I'm going to add it again this week. I want to point out something. If you look at competency 4, it's 33% of your exam. It's the most heavily weighted competency in the whole exam. And I actually love that for you guys, because what's beautiful about this is, unlike competency 3, and competency 2, those are difficult math skills, very difficult math skills, and it requires some practice and review. What I love about competency 4 is it's very easy to reteach yourself this math. Very easy, some quick reviews, some quick lessons like we're going to do today, and that is going to get you so far. So there's lots of questions for this competency, but the math really isn't that difficult. So I call this the bang for your buck competency. You put a little bit of study time here, you're going to get a lot of bang for that time investment. Okay, so if you're weak in competency 4, this is an easy way. Study here. It doesn't take a great deal of time and practice. Get better. And if you missed a bunch of questions in this competency, especially if you're retesting this exam, you can go back and do much better if you get these questions right. It can push you over the hump to get that passing score. So we're going to look at these skills in competency 4 today. Now, there are some terms you need to know, and I put most of them on here. Types of graphs. Now, we're going to be pulling questions from the released questions on the FTCE website. So we're going to be looking at those. There's not a lot of graph questions there to pull from, but just know that these are listed in that competency language we just looked at. So you need to know what these types of graphs are. So I'm going to go over that really quickly, and I'm going to add 2 to this. They're actually pretty easy, but I want to make sure you know. So bar graph uses bars to show comparisons between categories of data. A line graph connects data points with line segments. Good thing to know about line graphs is they're great for showing changes over time. A pie chart is a graph where the circle is divided into sections to show proportions of that whole. So whenever we're looking at a whole split up into parts or percentages, A pie chart's is very helpful for that and looks again at categories. A dot plot is a graph that uses dots to show the frequency. Those are used for small sets of quantitative data, so it wouldn't be a really large set over a long period of time. A stem leaf plot or a stem plot is where the data value is split from a stem into leaves. And so if you're not familiar with this, just Google it. You'll see lots of examples. The one that tends to hang people up is down here, this last one, histogram. It looks like a bar graph. It really does. So it groups data into ranges and it uses a bar to show a range. Whereas in a bar graph, that bar shows the category and one value, either drawn vertically or horizontally, but a histogram shows a range of values. So this is really good when we're looking at summative data that's a large data set. So that's where a histogram comes into play. Now there are two others on this list that are not mentioned, and those are picture and pictograph. And I want to talk about those for just a second. A picture graph is going to be where an actual picture is shown. So say we surveyed kindergartners on their favorite fruit, okay? We would have a grape standing for grapes, an apple standing for apples, a banana standing for bananas. And if we had 6 kids pick banana, we would show 6 bananas. That is a picture graph. You're using the picture. A pictograph is very much like a picture graph, except one picture stands for more than one data point. Okay, so same example, students voted favorite kind of fruit. Maybe we had 12 students say banana, and in the key, it shows you that one banana actually stands for 3. Okay, so we're looking at a larger data set where the picture graph would get too big. We can use a pictograph. The only difference is in picto, that picture may represent more than one. So just to know that on top of this, that's the graphs we teach in the primary grades. Okay, now we're not going to have a lot of questions on these today, so I wanted to be sure that you need to know the types of graphs and what they're good for. Okay, now we're going to jump into our questions, and as I said earlier, all of our questions come from the FTCE website. There's free public practice questions. And what I'm doing is providing explanation, because they tell you the answer, but they don't actually tell you why the right answer is right and the wrong answer is wrong. So let's talk about this one. This first one's looking at probability. And it says a child has 26 pennies, 15 nickels, 21 dimes, 18 quarters in a coin bank. When the child picks up the bank, a single coin falls out. What is the probability that that coin is a quarter? So we're looking at probability. All right, my pen's hesitating, so I'm just going to switch to my mouse. Of a quarter being the single coin that falls out. So that's all important stuff we need to know. A single coin falls out. Now I'm going to give you a little background teaching here. All probability is the likelihood of an event occurring. And we're looking at comparing values. So it's just the likelihood. A probability of 0 always means the outcome is impossible. It's not possible. So for instance, in this scenario, it's not possible for a $50 to fall out because that's not a coin in here. So it has a probability of 0. If it's a probability of 1, that means the outcome is certain or guaranteed. So in this case, we know it's going to be some form of coin that falls out. That's certain. So it has a probability of 1. Every other thing is going to be between 0 and 1. So we're looking at a fraction or decimal for that answer. So a fractional part of that whole guaranteed probability. Now, other things to know about probability. There's theoretical and there's experimental. So theoretical is the probability of what we expect to happen in theory. So just working with the numbers, which is what we're doing in this question right here. Experimental is what happens when we actually do a simulation or a trial. So we pull out a coin and see what happens, pull out a coin and see what happens. That's the experimental probability. Now, the more experimental trials you do, the closer you get to the theoretical probability. That's a key thing to know. So that theoretical is out there, and the more trials you do, the closer you are going to get to that theoretical probability. That's why we like to do lots of trials when we do an experiment. Now, when we go to write probability, which is what it's asking you to do in this question, we write it as a fraction, okay? The top number is the number of ways the outcome can occur. So in this case, we're looking for quarters. That's what we're looking for, that outcome. The bottom number is the number of different outcomes, so the total that could occur. Now, you can write this as a fraction, or you can convert it to a decimal or percent, okay? So think of it as like this, blank out of blank chance. So a quarter has a blank out of blank chance of falling out of this bank, okay? So really, we look at, this is quite simple, how many quarters are in the bank? Well, there's 18, so I'm gonna write my 18, and I'm gonna write this as a fraction out of how many total possible outcomes. So I'm just gonna add these up, and I'm gonna pull up my calculator. You could certainly do this by hand. It's not difficult math, but for the sake of time, I'm just gonna go ahead and plug it in that calculator, but apparently I typed something wrong because I got a really large number. That is not possible. All right, and we get here 80. So I have 18 out of 80 coins. Now you're probably thinking, but Dr. Mulkey, that answer choice is not there. You've got to reduce the fraction, okay? So we're going to reduce this fraction and figure out what would it be. Now, I know because they're both even numbers, I can divide both of these, the numerator and the denominator, by 2. So if I divide 18 by 2, I'm going to get 9. And if I divide 80 by 2, 8 divided by 2 would be 4. So it would be 40. 9 out of 40, B is the correct answer here. Okay, so quite simple. Once you know how to write probability as a fraction, and if you can reduce that fraction, you are ready to go. So probability is actually pretty easy. Now, I do want to talk about something. This was a single event, not a compound event. So if we were talking about this happened again, what would the likelihood of a quarter be falling out again? Well, did we put it back? Did we leave it out? When we're looking at a compound event, that's different. And if you want to know more how to do that, you can ask me in the comments. I can give you an explanation. If you're a 240 tutoring user, it's in our study guide. It explains it very well for how to find the probability of a compound event. All right, let's look at this next one. We have a bar graph here, and it says, a consultant uses the following graph to justify why air conditioning costs are higher in 2014 than in 2015. What aspect of this graph makes it misleading? So this is not just about reading the bar graph, okay? So we can see we have 2014 clearly right here, and 2015 right here. And we're just going to work ourselves through these answer choices. It says the bars are different heights. Well, in most bar graphs, what do you know? The bars are different heights. Unless all your data points are the same, your bars are going to be different heights. So that's not misleading. That's pretty normal. But we want to know why we're justifying air conditioning costs higher in 2014 than 2015. B, the vertical axis does not start at 0. Now, something you should know, and I'm going to give away the answer here, is when we're looking at graphs, we want to, as much as possible, show the baseline of 0. So we would want this bottom line to be 0. But actually, if you look at this scale, this bottom line would be 49. All right, so it makes the graph a little misleading that it doesn't start with 0, because it makes it look like the graph's actually growing more than it is, or those bars are raising more than they are. Because if you look over here, our scale is in increments of 1, 51, 52, 53, okay? Answer choice C, the scale on the horizontal axis is too large. So horizontal axis would actually be this one, and we don't actually have a scale here. The scale is on the vertical axis, and The scale isn't too large. It's only counting by 1. So I can clearly rule out C. The increments on the vertical scale are not equal. 50 to 51, 51 to 52, 52 to 53. Those are equal. They're all 1-point increments. So we can rule out answer choice D. All right. So that leaves us with A and B, and the correct answer here is B. In most bar graphs, we're going to expect the bars to be different heights, but you do want, for future reference, you want that scale on that axis to start at 0. That avoids misrepresentation. It avoids misrepresentation. All right, let's look at the next question. It says a marketing company wants to determine the consumer attitudes about a brand of soap in a particular city. Which of the following graphs would make the best survey sample? So what you're needing to know about is a survey sample. So let me give you a little background information on what those things are. A survey is just a list of questions to gather information from a sample in order to make a statement or conclusion about that population. So we survey a portion of that population to try to get an idea what the whole population thinks, believes, feels, whatever it may be. We're trying to make a statement or draw a conclusion about that large population by surveying a sample of it. Now, a sample is a subset of the population. So the population's everybody, right? The sample's a subset, and they're used because population is often too large that so large that it's not feasible to gather data. Like I can't survey every teacher in Texas. There's no way I'm going to get every teacher in Texas to fill out a survey. So instead of trying to survey every teacher, I'm going to get a sample, a subset of that population. Now, more specifically, a random sample is a sample in which each member of that subset has an equal probability of being chosen. So I randomly pick teachers in the state, okay? So a random sample is great because it helps avoid bias, which occurs in some parts of the population that are overrepresented and some that are underrepresented. So we're trying to avoid that bias. We want it to be a random sample whenever possible. So let's work through these. We need a survey sample of people in a city. Now, obviously, we're not going to get everybody in the city to take a survey about a brand of soap. So we need people who buy soap, all right? Or people in general in the city who buy something, okay? So let's look at these answer choices. A says, customers who regularly purchase the product. Okay, so what's tricky about this is we've got to look at, we want a sample. If we just pick people who buy this product regularly, we are getting too specific. We're eliminating the people that might buy it occasionally or the people who don't buy it all because they have an attitude about that brand of soap. Maybe I don't like Dial and I don't buy it. Well, if I only survey people who regularly purchase, I'm biasing that data because if they regularly purchase, they probably have a certain attitude about it. So A is too specific for our survey sample. B, registered voters who tend to vote in every election. Again, you're getting very specific and targeting a specific group. And I really don't know what voters have to do with this and why wouldn't we want to ask people about soap who don't vote? All right, or maybe they just haven't registered. So B is too specific. C, residents who are selected using a random process. Guys, when we want to do this kind of survey, random is going to be best. So we think C is the answer. D, employees who work for one of the town's largest firms. All right, again, we're getting a specific audience. Whenever we pick the audience like this, we're biasing the data. We want that to be random, if at all possible, okay? So the best answer here is C. All right, this next one, it says an ecologist takes 0.05 or 5/100ths of a milliliter drop of water from a stream and examines it under a microscope. The ecologist counts 25 examples of a particular microorganism. Using ratio and proportion, the ecologist infers that there are 5/10 or 0.5 million of these organisms per liter of water in the stream. Which of the following is the most important assumption that the ecologist makes with this inference? Okay, so there are some key things in here. It tells you the math using ratio and proportion. All right, that's how they made their inference. That's how they made their inference. So if we actually wrote this up as a proportion, we started with 0.05 milliliters, all right, and he saw 25 in there. I should have left myself a little more space, all right, and we said that equals now 0.5 million, so he went a lot larger here, in 1 liter, all right, liter, I'm gonna write that out because it's a little deceiving here, in 1 liter. So we know that a ratio and proportion was used. So let's think about this. Let's think about this, okay? What did I just say about samples? The last question. We're trying to get a subset there. We're trying to get something that represents the whole. He pulled out something that he thought would represent the whole right there. Okay, so we know he took a sample and used that to draw a conclusion about the water in that stream in general. So should it be a light bulb going off that this is a sample? So let's look at this. The drop of water was a representative sample. Guys, I'm gonna go ahead and tell you that is the correct answer. And it's storming so bad here. My pen and mouse and internet are all sketchy. So bear with me while that mouse hesitates just a little bit. Though B, no water evaporated while on the microscope slide. Okay, that could be true, but does that have anything to do with ratio and proportion? No, so we can rule out B. The organisms were not affected by the microscope light. Again, doesn't have anything to do with ratio and proportion. Rule that one out. All equipment was sterilized after the test was conducted. Again, has nothing to do with the ratio and proportion that he used to draw his conclusion. So here, remember, when a scientist takes a sample of something, it's much like a sample population of a survey. They're trying to use that sample to draw a conclusion about a larger set of data. Okay, so here the sample of water from the stream to draw a conclusion about a whole liter of water from the stream. One tiny drop versus a whole liter. So that is your answer here. Let's go ahead and move to the next question. This one says a company's human resources department is tracking the percentage of employees out sick and the relative humidity of the air in the building. Which of the following conclusions can best be inferred using the following data? See, these all require thinking. So if we're looking at this graph here, we've got all these dots scattered out, okay? Scatter plot, you can call it that, all right? It's actually looking at two variables by plotting a dot at each of the data points. So we're saying 5 people out at, 1% humidity, or, let's try to find another one that's easy to look. 10 people out at 40% humidity. So everywhere those data points meet, a dot is placed on the graph. Okay, now let me tell you something about a scatter plot. Unlike a line graph, the dots are connected, okay? But these kinds of graphs often contain what we call a line of best fit, okay? And so we can draw a straight line basically through the center or where we can get in the middle of all those data points. So if I were to do that here, our line of best fit with my hesitant mouse would be somewhere in that range, okay? Going up through the middle there, all right? Now this line of best fit You don't need to know it for this question, but you may need to know it for another. If it is a positive correlation between the two variables, you will get that line that's going up. A negative correlation indicates one variable increases and the other decreases. So you'll see the line going down. So a positive correlation means both numbers are increasing. We're going up the vertical axis and further down the horizontal axis. It's going a negative correlation where it's going down. That means we're going down the vertical axis, but we're still moving forward along that horizontal axis. No correlation indicates that there's no relationship between the variables, and so you won't see a line going one way or the other. The dots will just be all spread out and random looking, okay? So that would mean there's no correlation. So if you get a question about what type of correlation is shown here, remember if it's going up like this, up towards your right hand, then that is a positive. If it's going down, it's going to be a negative. If they're all over the place, there's no correlation. All right, so this one shows a positive correlation. Now, here's the thing you need to know to answer this question, and it's a common mistake. If you've ever taken a statistics class or a research class, it's preached heavily in research. This is a phrase you will hear often. Correlation does not imply causation. So just because two data points correlate does not mean that one caused the other, okay? Correlation does not imply causation. You cannot say that just because a correlation exists, that there is a cause and effect relationship between the two variables. So in this case, this is a correlational graph. It's showing you correlation. It does not mean that humidity is causing people to be sick. So now let's look at these answer choices. Answer choice A, high values of relative humidity cause people to become sick. Correlational does not imply cause and effect. So A is not correct. When many employees are out sick, the relative humidity tends to be high. Well, that's what this graph shows. When lots of people are out sick, the relative humidity is high. So that appears to be the answer. C, many employees are getting sick from mold and mildew in the building. We're drawing a causation here. We're trying to imply cause, that the humidity is causing, you heard what I said there, mold and mildew, and that's causing people to get sick. So nope. The negative effect of overcast, sunless days is influencing employees' health. Humidity might go up as it's overcast and sunless, or go down. It could go either way depending on where you are. But this, again, it says effect. We cannot establish a cause and effect relationship based on correlational data. The only answer this could be is B. When many employees are out sick, the relative humidity tends to be high. That's what it says. Those two things correlate with each other. All right. So just remember, scatter plot, positive correlation, it's going up. Negative correlation, it's going down. All over the place, there's no correlation. And no matter what, correlation does not create a cause and effect relationship. All right. Last question for today. The mayor of a city announces that there are 50% fewer automobile accidents this year than last year. Which of the following is the most important additional piece of information needed to properly interpret this result, or these results? So we have last year, we had a certain number of deaths. All right, that was last year. Then we have this year, I'm just abbreviating last year, this year. And we know there were a certain number of automobile accidents, okay? So we had automobile accidents here and automobile accidents here. We know that this year there are 50% fewer. Now, if we want to interpret that, we need to know something. Well, if I want to find 50% fewer, I need to know, ooh, that was fun. I need to know what was the number here so that I can determine what's the number here. Because it makes a big difference if there was one act or 2 accidents last year, well, 50% of that would be 1. That's not a huge change, okay? But if there were 100 accidents last year and 50% would mean we're down to 50. Well, that's a big change. So what we need to know is what would go right here. What is this missing data right here? So if we look at our answer choices, it says the total number of accidents each year. All right, that would be helpful. That's what we're looking for. The total number of cars registered in the city. Does that help us with this at all? Nope, not even related. The traffic density on the roads where the accidents occur. We are trying to interpret this data. That's completely separate data, a whole other variable. The number of dangerous intersections that were redesigned. Again, it's introducing another variable. To interpret this data, what we need is the total number of accidents each year. We need to know this. And if we know this, then we can calculate this. All right. So we need to know that total. All right. Now, if you are wanting some additional help, I want to point out that we now have videos in our study guide. So if you are not a 240 Tutoring subscriber, you can go check us out. If you are, go look in your study guide. We have videos on graphs and plots, on data analysis, on measures of center and range. Oh goodness, technology never cooperates. Okay, I'll try to get it to be still. All right, so we have videos embedded in our instructional content. I also want to show you that we have written instructional content along with videos. Oh my goodness. My computer is like possessed today. I'm going to try to stop touching it. Okay, so we have that instructional content in the form of written content and videos. So if you go back and look at that previous slide, everywhere you see a play button, that arrow pointing forward, that's a video. Where you see the circle, that's written instructional content. We also have flashcards, which is really helpful for learning, especially like these types of graphs and those types of things. And we have quizzes. So as you read and watch videos and study those flashcards, you can measure, formatively assess your own progress, all right? How much you're learning before you go and take a full practice test. All right, now I always recommend that you know your test format. You've heard me say this in any video if you've seen these. Know the number of questions, know the time limits, know that structure. Practice with the on-screen calculator, practice with that reference sheet that's there. Also practice your pacing. Competency 4, you should be able to move through these pretty quickly. I moved through 6 questions pretty quickly, and I was doing a lot of teaching and explaining. If I was just answering those, they should go pretty quickly, but practice that pacing because you want to save your time for the questions that actually ask you to calculate and do a lot of math because those are going to take longer. Here is your reference sheet. I highly recommend you get familiar with this. It's going to heavily influence your geometry and measurement questions. Now, if you would like more information about our study guides, I recommend you check out this bottom link right here. It's 240tutoring.com/study guides. You can see that we have a study guide for the general knowledge exam, math, and lots of materials there, like I showed just a minute ago, that will help you prepare. If you would like some free resources, you can check out 240tutoring.com/resources. We have a free diagnostic test and other things to help you prepare. Now, if you want to go back and see more videos like this, they are all in our Facebook group, or you can check out our YouTube channel, and we have a playlist specifically for FTCE and Florida GK exam. So I hope this has been helpful, and I'm so glad you tuned in. If you have any questions, even if you're watching this after the live is ended, go ahead and drop those in the comments. I do come back and check them, and we'll try to answer as many of those as I can. I don't see a comment that needs to be answered at this moment. Sorry, you could hear me clicking on it to see the comments. But if you drop one in later, I will come back and answer that and try to help you as best I can. So good luck as you prepare for your exam. Again, I'm Dr. Christy Mulkey with 240 Tutoring.